We are given a projectile that starts at 8 meters per second at an angle of 30 degrees with the horizontal. And the question is to find the maximum height of this projectile. Let's call the starting point as A and the end point as B. And the maximum height that happens here, we'll call it point P. In projectile motion, we always resolve the component. We write x and y. We have the x component of velocity as 8 cos 30 degrees and the y component as 8 sin 30 degrees. Let's start at point A. When you throw the projectile and you are only interested in the maximum height, you measure the height vertically, and the vertical axis is the y-axis. So only worry about the y component for now. The y component of the velocity is 8 sin 30, which is 8 times 0.5, because sin 30 is 0.5, which gives you 4 meters per second. That's the Vy. We look at the projectile starting at A and going to P. Let's only worry about this part of the journey. A is the initial point and P is the final point. So the velocity at A, the y component of velocity, is the initial velocity, 4 meters per second. The final velocity is the velocity at point P, which is 0. We know that the y component of velocity at the highest point is 0. We also know that in the vertical direction, A is minus 9.8, and we are trying to find the displacement in the y direction. Now we have Vi, Vf, A, and we need D. Find the equation that contains these 4 variables, Vi, Vf, A, and D. That would be the last equation. So let's use that one. Vf square equals Vi square plus 2AD. Plug in the values. Vf is 0. Vi is 4. A is minus 9.8. And D is just D. D would be this, which is the height. This is 0 equals 16. 2 times 9.8 is 19.6 D. From here, D would be 16 over 19.6. Use the calculator and you get a value in meter. That would be the distance in y, which is the maximum height that the projectile travels. This is the exact method you will follow to find the maximum height of the projectile. Start by finding the y component of the velocity. That would be your initial velocity. The final velocity at the highest point would be 0. Use A as minus 9.8 and then use this equation, plug in all the values and find D. That would be your maximum height. If you understand this, try this problem. You have the initial velocity, you have the angle. Find the maximum height of this projectile. Use the exact same method as the last example and you should be good. Write your answer in the comments below.